Hello, student. This is video number 4 related to the magnetic materials. Here, just now I derived the equation, that is, derived the relation between what permeability, susceptibility, and all that. Here, now I'm going to discuss the comparison between diamagnetic, paramagnetic, and ferromagnetic. Students, remember one point. Always paramagnetic material and ferromagnetic materials are having almost the same properties are there. Only the diamagnetic materials are having the entirely different properties. Remember, first one, normally it is a 4-mark question, it is easily to write, easily you can write it. Here the net magnetization is 0, net magnetic momentum equal to 0 in diamagnetic material. But in the paramagnetic material, the M is net magnetic momentum is not equal to 0. Why it is not equal to 0, I will tell you later. Here also for the ferromatic material, the net magnetization is not equal to what? 0 here. Second one, they are strongly what? They are repelled by the magnetic field. They are repelled by the magnetic field. They are attracted by the magnetic field, but these materials are strongly attracted by the magnetic field. Attracted means material is attracted by the what? Applied magnetic field. Third one, whenever such material is placed in the non-uniform magnetic field. Remember, there is a difference is there. Uniform magnetic field and non-uniform magnetic field. In a non-uniform magnetic field, always they move from stronger to weaker. There is a confusion. Why it is stronger to weaker? Because they are repelled. They are what? Repelled, that is. Next, paramagnetic material, they are attracted. That means they are attracted. They are moving from what? Weaker to what? Stronger magnetic field. Similarly, ferromagnetic material also, they are moving from the what? Weaker to what? Stronger magnetic field. And also, next fourth point, here the relative permeability is what? Less than 1. Why it is less than 1? I told you in the previous video, that is. Here it is mu r is greater than what? 1. Slightly I have written. Why I have written slightly is the chi is what? 10 to the power of minus 3 to what? Minus 6. And here it is both are positive quantity. Here it is mu r is relative permeability is very, very high. It is greater than 1 here, that is. Next, susceptibility equal to what it is? Negative it is for the diamagnetic material. This is for the positive. This also what? Positive. As I told in the previous class, the value of susceptibility is minus 10 to the power of minus 3 to minus 10 to the power of what? Minus 9 is that. But here it is positive, it is 10 to the power of minus 3 to 10 to the power of minus 6. But some books they have mentioned 10 to the power of minus 5 also, no problem. Here, this susceptibility value is nearly equal to what it is? 1000, that is. This is 1000. Next, examples of this is diamagnetic is what? Nitrogen is there, copper is there, hydrogen is there, water, very important, I think probably studied in chemistry also. Here, the diamagnetic, water belongs to what? Diamagnetic material. Copper is also belongs to what? Diamagnetic material and all that. And paramagnetic material example is aluminum is very good example. Aluminium, calcium, sodium and all that. Here I have written the atomic number also I have written that is. But most of the materials which are having the atomic number odd number now, not compulsory that is. They are having, definitely they exhibit the permanent magnetic dipole moment is there. Because their spin angular momentum is not equal to 0, so that is most of the atoms which are possessing an odd atomic number, they are comes under either paramagnetic or else what? Ferromagnetic material. Very good example for the ferromagnetic material is iron, cobalt and what? Nickel and all that. Here I'll tell you why this mu r is less than 1. I told you in the previous class, you know the relation between the mu r and susceptibility. You know that. Mu r equal to 1 plus of what? Chi is. This chi is what? Negative is that. That's 1 minus something. But this value is what? Very closer to almost 0 here. That's why mu r is less than what? It is less than what? 1 here. But for this, it is chi is positive is there, so that it is mu r is what? Greater than 1. For this material, mu r equal to, it is 1 plus 1000, it is that very high quantity compared to what? 1 here. So that this mu r is what? It is greater than what? 1. Students, don't forget here. Normally there is one question is there. Write the comparison between diamagnetic, paramagnetic and ferromagnetic material. Next, I will discuss the origin of magnetic dipole moment for the diamagnetic material and also for the paramagnetic material. That is called as Langevins theory. That is Langevins theory. Langevin is the name of a scientist who studied a lot on the magnetic material, on the classical theory. Because there is two theories are there. One is classical theory and another one is quantum theory is there. But for your syllabus, only the classical theory is there. Langevins theory of diamagnetism. Langevins theory of paramagnetism. Okay. Students, one thing you remember. Here at the center nucleus, and this is what? Electron is there. This electron, it is making the two kinds of motion it is making. One is orbital motion and another one is what? The spin motion here. One is orbital motion. It exhibits orbital angular momentum. Orbital angular momentum. And another one is a spin angular momentum. That is spin angular momentum. Here, for all paramagnetic materials, here, when the orbital angular momentum means electron rotates in the what? Around the what? Nucleus in the circular fashion. The spin means it rotates about its what? Own axis and all that. That is how day and nights are happening. Earth rotates about its own axis. That's why you are getting, for every 12 hours, you are getting day and night. Earth rotates around the sun. It is an orbital motion. That is, in order to make one complete rotation around the sun, it is what? 1 year equal to what? 365 days are there. Since electron is a charged particle, so that when it is motion, the current is there. When there is a current, there must be what? Magnetic field is there. When there is a magnetic field, there must be a magnetic momentum. Magnetic momentum. Mu, I will use the word. The magnetic momentum is for each atom, I call it as magnetic momentum. Magnetic momentum of each atom, that is, of each atom. This is notation I am using in the next derivation and all that. Here it is, contribution is there because of orbital and also what? Spin, that is. As I told you in case of diamagnetic material, that is susceptibility is negative and all that I told you, where there is no atomic dipoles, I told you. For example, in case of water, okay, in case of or else, in case of what? Helium. What is atomic number? 2. In atomic number 2 means one is with spin up and another one is what? Spin down. There is an electron pair. In this electron pair, that is net spin equal to what? It is 0 here. As I told you, there is odd atomic numbers. Aluminium, atomic number, it is an odd number is there. That is valence. That is. Here, if there is only one electron is there, then what happens? This will be like this. It is not cancelled because there is no pairing. Because on the outermost shell or in the valence shell, only one electron is there. But in this valence shell, the 2 electrons are there. Because of electron pairing and all that, the net spin equal to what? 0 here. That's why here the spin angular momentum is 0 in case of what? In case of what? Purely dielectric materials and all that. I don't want to create a confusion here. Totally, the Langevins theory, what it says here, whenever the electron rotates around the nucleus, what happens? Here it exhibits the 2 kind of motion. One is orbital angular momentum and also what? The spin angular momentum. When electron rotating means the current is flowing. Because of that current, then what happens? A magnetic field is what? Produced here. That is. When it produces the magnetic field, that means each atom acts like a what? Magnetic dipole. That is called as a dipole moment. That is what mu, that is. Next is here for the diamagnetic material, what happens is for Langevins theory of diamagnetic. In diamagnetic, here, diamagnetic. Here, there is no contribution made by spin angular momentum. No contribution made by spin angular momentum. For example, I told you that is atomic number is even number. For even number, that electron pairing is there, so that no spin angular momentum and all that. And you will ask question, what about orbital angular momentum there is? But here also, in one electron rotates in the circle in the clockwise direction, and another electron will be rotates in the what? Anti-clockwise direction and all that. Because of this clockwise and anti-clockwise motion, here the net orbital angular momentum is also what? 0. So that there is no magnetic dipoles. There is no magnetic dipoles. There is no magnetic dipoles. When there is no magnetic dipoles, then magnetic momentum equal to what? It is 0. Or magnetization equal to what? 0 and all that. But remember, whenever such kind of diamagnetic material is subjected to the external magnetic field, what I discussed is in the absence of external magnetic field. When diamagnetic materials are subjected to, when a diamagnetic material is subjected to a external magnetic field, what happens is here velocity of the electron changes. You may ask question, why the velocity of the electron changes here? Velocity changes means there must be acceleration. When there is an acceleration, there must be what? Force should be act on it here. Here, induced EMF is produced. You see, very interesting. Induced EMF is produced. When there is a EMF, that means voltage is there. Electron is a charged particle, so that the force will be acts on it. The force will be what? Acts on it. According to Lenz's law and all that. When there is a force equal to what? Mass into what? Acceleration. Then acceleration equal to what? dV divided by what? dt. Yeah. That means when there is a dV means the velocity is what? Changes here. What is the conclusion in case of diamagnetic material? In case of, if there is in the absence of external magnetic field, the contribution made by the orbital angular momentum and spin angular momentum is 0. So that all diamagnetic material exhibits no magnetic dipole moment. No dipoles are present. But if you apply the external magnetic field you apply here, then what happens? It produces the what? Well, induced EMF is produced. Voltage is produced. When there is a voltage is there, then there must be electrical field. That is F equal to what? E into what? E, that is. Then we know that in the mechanics, where is when the F equal to what? M into A. Acceleration is nothing but rate of change of what? Velocity. So the velocity will be what? Changes in case of what? That is a diamagnetic material. Whereas such kind of material is subjected to what? External magnet. This is what the Langevins theory on the diamagnetic material. Next, I will go to discuss the derivation on this paramagnetic and diamagnetic. Okay, thank you.